About cones. Okay, what does a cone look like? What does it mean?
Like that shape? No.
Well,
Like that triangle or
right. So this is an example of a cone, right? Yesterday when we did cylinders, it was pretty easy because all a cylinder really is a rectangle. You cut this down and spread it out to a rectangle in two circles, right? But a cone's different, okay? Because if I cut this down, like down the side, and I unroll, is that going to form a rectangle? It's like some kind of funky shape, right? Okay. And what is also involved?
Circle.
No matter what, there's a circle involved. So if there's a circle, we automatically know what also is involved.
Square.
Pi. Okay, pi is going to be involved. Okay. All right. Because pi has to do with circles all the time.
Isn't
Good.
pi related to circle?
Yeah, because usually a pie is shaped like
Actually, my friend made pie shape.
That's value. That's very, very good. Okay. All right. So let's think about what we're talking about when we talk about volume of a cone. Okay. Hayden and Chad are filling conical or cone-shaped bags with different types of treats. Hayden is filling the bags with popcorn. Chad is filling the bags with jelly beans. Hayden knows that more jelly beans fit into one treat bag than popcorn, but she wonders how much more. Okay.
You really need to know.
So what we're going to do.
No, he doesn't need to know. That's just a smart aleck.
Something you would do.
Okay. These are the vocabulary terms.
True though.
Shh. All right. Let's get started. Okay. So first of all, you're going to need a calculator. Okay. So if you don't have one, please grab one. Okay, so yesterday, the lesson was more than just about finding the volume of a cylinder. In other words, we didn't just find the volume, but we learned how to apply the volume, right? So it's kind of going to be the same thing here. We're going to learn how to find volume of cones, but we're also going to apply it to problems. Okay, now, when you see the formula up here, I'm going to show you a little bit different formula, okay, that I think will make a little bit more sense to you, okay? Basically, okay, if I look at a cylinder compared to a cone, these are almost the same size,
They are.
okay? They're almost the same size circle.
Oh my gosh, there's a party.
Okay, the thing is this going to be less volume than this?
Yeah.
Okay, so do you think it's about half the volume?
No.
It's actually more than half, okay? What the volume of this is, okay, think about this. If I had two of these, okay, they still wouldn't make up the entire volume of this. And so the way that we find the volume is we're basically taking the formula for finding volume of a cylinder, which is, tell me again, pi r squared times height, okay? And we're going to take that and we're going to divide it by 3. And that's going to give us our volume of a cone, okay? Now that's the same thing as saying 1/3 pi r squared times height, okay? But instead of multiplying by 1/3, we're going to take that and we're just going to divide it by 3, because to me that's easier. Whenever you have a 1 on the top, you can just take it and divide it by 3. Does that make sense?
Yeah.
Okay, so let's take a look at an example. All right, so if I have this, well, first of all, if you want to write down the definition of a cone, it's a three-dimensional figure with a circular base connected by a curved surface to a single point called the apex. Okay. Okay, if you want to write that down, the definition of a cone. All right, let's take a look at an actual cone. Okay, and we're going to find the volume. Okay, again, if we're finding it from a radius, okay, yesterday we were able to find the volume of a cylinder from a radius, right? We just plug it in. Okay, so it's kind of the same thing. Now, these formulas are both the same thing, but what I'm telling you, write this down. Write this down. Volume of a cone. Okay, volume of a cone. V equals pi r squared times height. V equals pi r squared times height divided by 3. Okay? So if I wrote that out, cone would be like this. V equals pi r squared times height divided by 3. Okay, which is the same exact thing as multiplying by 1/3. Okay? I like it better to just divide it by 3. So if we were to plug that in here, okay, first of all, what do these numbers represent? What does this 3 represent? The radius. So we're going to plug that in for R. What does that 6 represent?
The height.
The height of the cone. Okay, so let's plug those in. And as we look at this, okay, again, this is going to look a little different than the formula I showed you. Okay, but if we plug those in, we're going to have, tell you what I'm going to do. We're going to look at that one on here. Okay, so if I look at this, and I'm going to find the dimensions of that cone, the volume, sorry, of that cone. Okay, tell me what were the dimensions of the one we were just looking at?
3 for the radius and 6 for the height.
Okay. All right. So now, does it matter that this one is upside down? No. Okay, so this was 3, was it inches?
Yeah.
Inches, okay. And this was, what was the height? 6. Okay, so the first thing we're going to do is we're going to write our formula, okay? So volume equals pi r squared times height. We're going to divide that by 3. Now, just like yesterday, your calculus, if you put all of this in there at once, the likelihood that you're going to come up with something different is pretty high because your calculator sometimes gets order of operations mixed up, okay? But if I want to consider order of operations, what do I need to take care of first here? Take care of this what? This exponent, right? Okay, so volume equals pi. Actually, I can just write this as 3.14. 3.14 times 3 squared times 6. All of that divided by what?
3.
By 3. Okay, so plug all of that in. Okay, what do we have? 3.14 times, what's 3 squared? 9 times 6. All of that divided by 3. What's 3.14 times 9 times 6? 3.14. 169.56. And we're going to divide that by 3. So we'll say about 56.5. Now remember, because this is a circle, we're going to use our about sign, and this is going to be inches what? Cubed. Good. Okay, and that will be my final answer on that. Okay, does that make sense how we did that? Okay, it's pretty simple. Okay, it's basically the same exact thing as what we did with cylinders. The only change is we made that divided by 3. Okay, let's try this one. Okay, let's try this one, and let's see how we do. You guys do this next one on your own. Okay. Using the formula that we just did. Okay? Try that one. Let's see if you get it right.
Does that say 7?
That says 7. Height of 7 and a radius of 2. A height of 7 and a radius of 2. Bless you. All right, so we have a radius of 2. What was it? What was the unit? Feet? Okay. And we have a height of 7. Okay, so let's write our formula. Somebody tell me what my formula is for this.
Volume equals pi r squared, height divided by 3.
Good. Then we can replace pi sign with 3.14. What's our radius?
2 squared.
2 squared times what's our height?
7.
All that divided by 3. Okay, what is 2 squared?
4. It's not. Who said 9?
Okay, 3.14. 3.14 times 4 times 7. What do we get?
7.
And we're going to divide that by 3, and what do we get? Feet cubed. Good. Okay. Do we understand that, how we got that?
Yes.
That's easy, this first part. Okay, good. All right, let's continue. Okay. All right, the next thing we're going to talk about, okay, what is different when I have a situation like this? Okay, a cone-shaped paper cup is filled with water. The height of the cup is 9 centimeters and the diameter is 8. What's the difference in this one?
There's a diameter.
All we've done is given what? All that's different is we've been given a diameter. So if we've been given a diameter, what do we need to do with that? Divided by 2 so that we can make that diameter into a radius. Okay, good. Now, do I need to actually go through that? I think you guys are okay with that, right?
Is it 4?
The radius would be 4, yeah. Okay, so let's look at this one. Okay, this one we're given a what? We're given a radius. So all we've got to do is plug in these numbers, we're good to go. Okay, now when we actually apply this stuff, okay, that's where it gets a little bit, I don't want to say tricky, but we have to apply our brains a little bit. Okay? If we say on this one, a family-owned movie theater offers popcorn in the sizes shown. Their cost for the popcorn is 9 cents per cubic inch. If each container is filled to the top, what is the difference between the cost of the popcorn in the two containers? So, first thing we have to look at these. What do we have here? What is this? This is a cylinder, which we can find the volume of, right? What is this second figure? It's a cone, right?
Why are they selling popcorns?
That's what I was saying.
Okay, so the first thing we're going to do, let's find the volume of this cylinder, okay? This volume, this cylinder has 4-inch, what is that for? Is that diameter or radius? It's a diameter, so we have a 4-inch diameter, 6-inch height. Okay, so let's go to our work screen over here. Okay, let's get rid of this.
Wait, can you go back?
And we have a 4-inch diameter. Okay, and then we have a cone over here. All right. So we're going to look at both of these shapes. Did anybody write those down, what those were? Okay, so they both had a diameter of 4, right? Okay. So this was all the way across. Was 4. Was it inches?
Yeah.
And this all the way across was also 4 inches. Okay, what was the height of each one?
6.
Okay, so 6 inches, and this was also 6 inches. Okay, so the first thing we need to do, before we can figure out the difference in cost, is we need to figure out the volume of each one of these, right? So let's first find the volume of this one. Who remembers the formula for volume of a cylinder? What is it? Times height, good. So volume equals 3.14. Now this is a diameter, so my radius is 2, right? So 2 squared, and the height is 6. Okay, so volume equals 3.14 times 4 times 6. So volume equals 3.14 times 24, and what do we get? 75.36
inches cubed.
So let's round that to 75.4 inches cubed, okay? That's the volume of this one. Now let's find the volume of this one. Now, do I have to think about this for a second? Do you think I need to go through all these steps? What can I do? These numbers are the same, aren't they? So the volume of this is exactly the same, but I'm just going to do what with it? Just divide it by 3, okay? You can do the extra work if you want to, but you don't have to. I can take 75.4 and divide it by 3, and what do I get? 25, so we'll say about 25.1, and that's inches cubed. Okay, so how are we going to apply this now? Let's go back to our problem and see what it says. Okay, our problem says the cost for the popcorn is 9 cents per cubic inch. Okay, we want to find the difference. So what are we going to have to do with that 9 cents? Think about this. 9 cents per cubic inch.
You multiply it.
So what are we going to do with that? We're going to multiply it by what?
3.
Okay, this one is 75.4 cubic inches, so we're going to multiply this times 0.09. Okay, tell me what you get when you multiply that. 75.4 times 0.09.
6.8.
6.78.
If you round it.
So about 6.8, okay? So this, we'll just say this is, the cost is about $6.80, right? Okay, now let's do this one. 25.1 times 0.09.
2.259.
And what'd you get?
2.
So that one's about 2.26, okay? So about $2.26. Now, I still have another step. It asked me to find the difference in cost between this and this. So what am I going to do with those? Subtract it, okay? So $6.80 minus $2.26, and what would I get?
$4.54.
So the difference, my final answer would be $4.54, okay? Do you see how we were able to find that? Yes? Okay. All right. I'm about out of time, so we'll continue this tomorrow. I'm not going to give you homework tonight.